Hi, everybody. This is Math 60 video lecture for section 1.4, which is about equations, inequalities, and solutions. So we've already seen what equations are. Equations are things like x equals 17, or 2x plus 1 equals 15. It's a mathematical expression involving an equal sign. Inequalities, we've seen some of those, are things like x is less than 2, or x is greater than 4, or maybe minus 7 is less than x, which is less than 13. And solutions are which x values make the expression true. So equations and inequalities are both types of mathematical expressions, and those expressions can be true or those expressions can be false for different values of x. But let me give you some examples of true equations. Three equals 3. That's a true equation. False equations. 5 equals 1. That is false. True inequality. 2 is less than 3. That's certainly true. 3 is less than or equal to 3. That's also true because 3 is less than or equal to 3. And false inequalities. 5 is less than 1. That is false. 1 is greater than 5. Also false. So when you're using these equations and you're asking if they're true or false, it's really easy if they're all numbers. But variables allow equations and inequalities to be true or false depending on the value of the variable. So, and a solution to an equation or inequality is the value, and there may be more than one, of the variable that makes the equation or inequality true. We talked a little bit about this in the preview video when I talked about solving equations. So let's look at some examples. X equals 2 is the solution to the equation x plus 1 equals 3. Because when x equals 2, 2 plus 1 equals 3, so 3 equals 3, and that is true. X equals 2 is one of the solutions to x plus 1 is less than 4. Because when x equals 2, 2 plus 1 is 3, which is less than 4. However, x plus 2 is not just the solution, it is the only solution to x plus 1 equals 3. And x equals 2 is only one of many solutions to the inequality x plus 1 equals 4. So inequalities have intervals as solutions. And equations have one or more distinct numbers as solutions. In our first example, x equals 2 is the only solution, whereas the solution to x plus 1 is less than 4 is actually all x, less than 3, right? So it's actually an interval that can solve this. Many equations have a single solution, but some equations have multiple solutions. So for example, is 2 a solution to x squared equals 4? Well, we can check that by plugging it in. X squared equals 4. Replace that with a 2. We're now evaluating an expression, so I'm checking both sides, and I get 4 equals 4. Yes, 2 is a solution to x equals 4. But that's not the only solution to the equation x squared equals 4. And I think I said x equals 4 just earlier. But 2 is a solution to x squared equals 4, but so is negative 2. Because we can check by taking x squared equals 4 and plugging in negative 2 for x. When you square something, you're multiplying it by itself. And negative 2 times negative 2 is positive 4, and you're welcome to use your calculator to convince you of that fact. So we can have multiple solutions to the equation x squared equals 4, but they will always be distinct numbers. You won't have a whole interval of solutions. And let's just do an example where we check some other inequalities. Is x equals 3 a solution to the inequality 2x plus 9 is less than or equal to negative x plus 8? I don't know if it's a solution yet. I just made this up. So let's figure it out. So we have 2x plus 9 here, negative x plus 8 there, and we're going to replace the x with the 3. So we have negative 3 plus 8. So put that in parentheses. There we go. Next step, we get 6 plus 9. And here we have negative 3 plus 8. So on the left side, we have 15. On the right side, we have positive 5. And the question is 15 less than or equal to 5? No. So x equals 3 is not a solution, because it is not an x value that makes the inequality true. That's it. That's section 1.4. Checking equalities and inequalities for solutions. I'll see you for section 1.5.